Warm welcome to the Carmenta Stockholm office and this webinar around the UAS topic. It's a bit empty here in the office as we've all relocated to working from home in these times. I do hope that you and your loved ones are keeping safe during the pandemic. These are indeed strange times, but we're keeping open at Carmenta and doing business pretty much as usual, and we're here to support you in a way we can. The topic for today's webinar is taking your UAS missions to a higher level using real-time geospatial analysis. That will be the focus for today's topic. Before we dive into the agenda, I want to introduce myself and my colleague who will be handling the webinar today. So for you who don't know me, my name is Tobias Moberg, and I'm the head of product management at Carmenta Geospatial Technologies. That means that I'm responsible for the product suite that we provide, and also, of course, for the roadmap ahead. And as I think you'll see during this webinar, currently a lot of our focus is on the UAS domain and ensuring that our technology is a really good choice for these types of applications. I also have my colleague Dennis from our Gothenburg office on the line, and I'll hand over to you, Dennis, to introduce yourself.
Yeah, hello everyone. Actually, I'm at home now, but I'll introduce myself here. My name is Dennis Endo, and I'm a senior software engineer at Carmenta. I have several years of experience in the aviation industry, and I've been working with the airfield areas, including aircraft systems, UAS application, and situational awareness systems. Well, for today, Tobias and I, we prepared a presentation to show you some of the cool stuff that we've been doing here at Carmenta. I hope you all enjoy it.
Yeah, thanks a lot, Dennis. Yeah, so as you heard, Dennis has a long experience in this area, so he's a really good guy to have around here. So that also means that all the tricky questions that you can come up with in this field, which I'm sure you all know better than we do, I'll just field them to Dennis and hope for a really good reply there. Okay, so moving on to the agenda then, what we will cover during these 45 minutes. My plan is to start by giving you a short introduction to our geospatial technology, so that we're sort of all on the same page and know what kind of stuff it is that we do and what we focus on helping out with. After that, we will move on to the UAS use case, and we will give you two examples on how our technology can be used in this field. The first example will be around planning a flight in a city environment, a rather complex environment with lots of high buildings and so on, where we can help out with figuring out the best way for the pilot to be and the best route also to avoid these buildings and so on. Dennis will get more into that in that demo. The second demo will talk a bit about how you can plan and execute more of a recon type flight where you're doing flights over longer distances, maybe for reconnaissance purposes. In this case, you will mostly operate beyond visual line of sight. So it's really important that you can plan a route and that you get the right sort of situational awareness so that you understand your drone's surroundings, even when you don't have a visual lock on it. So those are two different use cases where you'll get some hopefully nice looking demos here that can give you some inspiration. If we have time after that, I also plan to take a few minutes to talk about some other important Carmenta Engine functionality that benefits the UAS domain. And finally, we will wrap up with a questions and answers session. There is functionality in the Zoom webinar client for asking questions via the chat function. Go ahead and use that during the webinar. When I'm speaking, Dennis will keep a look at the questions that's coming in. And depending on how much time we have in the end, we will answer a few of those. And of course, the rest of the questions we will follow up via email at a later point. So just go ahead and give us your questions as you see things which you find interesting during the actual presentation. Okay then, so that's the plan for the agenda. Jumping in then to the first part about our geospatial technology. What is it that we do at Carmenta? Well, I like to put it like this. we create technology that helps you visualize and analyze geospatial information. So let's dig into this statement a little bit here. First of all, I'm talking about geospatial information. I'm not saying maps here, because Carmenta and Carmenta's technology is about much more than just the background maps that you will use as your basis for your planning, for example. We are also very good at handling all the dynamic information that you want to put on top of those maps, be it your positioned vehicles or drones, be it live videos from your drone's onboard sensors, or real-time information from a radar system, for example. All this kind of dynamic information can be fed into our technology, combined, fused to create a updated picture, which can then provide this improved situational awareness, which is really our core as a company, about providing that situational awareness. I've also highlighted here that the technology does more than just visualize the information. It can also do quite a lot of different kinds of analysis to help you make sense of what's going on in the map. This little picture here is a quite good example of this. As you can see, it's a 3D map. It's using some different data sources here. There's a high-res orthophoto in the background. We, of course, have an elevation model to model the terrain correctly. There's also some buildings here. In this case, you see that we don't have access to a detailed 3D city model. Dennis will showcase some really cool looking 3D models later on, don't worry. But in this model, we just have the building footprints combined with the height of each building. So we're using that to build up these boxes that represent the buildings. And based on that information then, we can calculate the line of sight, or the so-called view shed, of objects inside the map. So the little symbol you see here is some sort of observer. In this case, it's using military symbology, so it's an enemy observer over there. And of course, the red areas, they highlight the view shed from this position. It shows you exactly what you can see. Can I, for example, safely plan a route for a VIP transport through this intersection over here? No, probably not, because that's in the view shed of that suspected position over there. So that's one simple example of how the analysis that's built into our tools can help you make sense of what's going on in the map. And you'll see more examples of this, many more examples, in the demos that Dennis will show later on. Some other key features about our technology. Well, it's designed to be very flexible when it comes to how you can actually deploy your Carmenta-based application. You can build everything from web-based solutions running completely in a web browser to mobile apps running on Android or embedded Linux, and traditional applications running on Windows and Linux. So we put very few limits on how you can actually deploy your Carmenta-based applications. Furthermore, our really strong focus is on the mission-critical use case. And what we mean by that is that systems where Carmenta technology is used typically have very high requirements on uptime and reliability and stability. It's systems that cannot fail. Might be a system which is used on board an aerial firefighting aircraft, like in the picture here, for example. The personnel on board that aircraft will trust that system to be up and running all the time and to not fail them in the really important missions that they do. And it's in systems like this that we really excel with our technology. We spend a lot of time ensuring that it has this stability that means that it can be trusted for these kinds of use cases. Some of the key technical benefits of our technology. Well, one important thing is that we really don't believe in converting or pre-processing your data that you want to use as part of your map. So our philosophy is that we connect directly to the data in whatever formats. So that means that out of the box in the technology, I think we support somewhere between 80 and 90 different data formats. They can just be connected directly and used both for visualization and analysis directly, both in 2D and 3D maps. We've also made it very easy to integrate these dynamic data sources that I talked about before into the technology. Be it, as I said, positioned vehicles or even video streams or radar feeds. A software developer has access to very efficient APIs for feeding this information into the technology for visualization and analysis. A third thing which is important for us is interoperability. And this is also something we believe strongly in. In order for a system based on Carmenta technology to be really usable when it's operationally deployed, it is important that it can interchange and exchange information with other systems out there. So we've made a strategic decision that our service interfaces, they all follow open and standardized interfaces, so that it's easy both to connect to systems from other vendors and bring in information into Carmenta, and also to provide information from your Carmenta-based systems to other systems. So interoperability, that's really key in our approach here to how you design a functioning system. So we're very nearly there to where we will actually see some cool looking UAS demos. Just one slide before that, summarizing the product suite from Geospatial Technologies. The core product that we provide is called Carmenta Engine. And Carmenta Engine is a so-called SDK, a software development kit, available both for Windows, Linux, and Android development, and also very flexible when it comes to the APIs that you can use for development. It supports both C++, C#, Java, and even Python development. So this is an SDK. It's a set of components that are designed for developers to integrate geospatial functionality into their own applications. The application that Dennis will use for his demos is actually an example of a Carmenta Engine-based application. We've just created that as a sort of mock-up to be able to showcase some of our analysis functionality. So the application itself is not a COTS product from Carmenta, but the underlying toolkit is. The other main product in our product suite is the Carmenta Server. Carmenta Server internally uses exactly the same engine as Carmenta Engine SDK. So it has access to same functionality for visualization and analysis. It can read the same data formats, but rather than providing APIs to the functionality, it provides web service, HTTP interfaces to the technology. Carmenta Server can be deployed both as a traditional server product and installed on a Windows Server machine, but it also supports Docker container deployments. There is a version of the server called Carmenta Server Core. It comes pre-packaged as Docker containers, both for Linux and Windows, and it's ready to be deployed both to public and to private clouds. So that's a bit of background to our geospatial technology, and now it's time to jump into the actual UAS demos here, which Dennis will handle. So two different use cases, as I said, from the UAS domain. In the first example here, Dennis will show you an example of how to plan a flight in a complex city environment using our technology. And before we get going with the demo, I just want to say a few words about this really cool looking 3D city environment that we're working with in this example. We're using a 3D model from a company called N-Frames. You can see their website address there. It's a really cool company. They're based in Stuttgart, Germany, and they develop software for 3D surface reconstruction using a methodology called photogrammetry. And the models that you get out of the N-Frames tool suite is optimized to be very precise and also very performant. And as you will see in Dennis's demo, they also work great in our technology. So it's a really cool company. I suggest you check them out if you have a need to create these kind of high-res 3D models. With that, we'll get into the actual demo. Just give me a second to fix the screen share here. Okay.
And now we are going to use this high-resolution Frankfurt City model to plan a mission for a drone. As you can see in our mission planning application, we can switch between the 3D model and the 3D map. From the 2D map, I'm going to start to create a route for my mission. Using my route creation tool, I can set the desired waypoints along the route, then it starts to be shown both on my 2D map and on my vertical profile at the bottom part of my application. The high-resolution city model can also be used to analyze the terrain elevation on my vertical profile. As you can see, the terrain along the route is calculated in real time while I move one waypoint around the map here. I'm going to move another waypoint, and you will see the terrain being calculated based on the building's elevation. On my vertical profile, I can also adjust the desired altitude for each waypoint. I can also set a waypoint to the ground elevation and have a landing point for my drone. This way it is easy and intuitive to create a mission route for my drone. After the route's planned, let's start the simulation and see what the flight looks like. As you can see now, we have the mission simulation running. We can also see the simulation running in a 3D environment using our City 3D model. Here I have placed my drone's pilot. We can use our high-resolution model also to analyze the line of sight of the pilot. In this mission planner here, I have set the line of sight of 500 meters for the pilot visibility. Thus, we can analyze which parts of the route is visible to the pilot and which parts hidden by the building shadow. As you can see here, we have the 3D visibility analysis. Now, let's move our pilot to another part of the map. I want to place the observer on top of this building here. Let's see what happens. And now, as you can see, our line of sight is instantly recalculated according to the new pilot's position. I'm going to move in again and see the pilot's sight coverage. And there it is. As you have seen here, our technology makes it really easy to plan and simulate or reproduce a real flight in a 2D and 3D environment using a high-resolution data source.
Okay, thanks a lot for that little demo, Dennis. Of course, as I mentioned before, feel free to ask any questions about what you just saw in the chat there, and we'll try to get to those at the end of the webinar. For now, I'll just try to summarize a little bit what we actually saw in this demo that Dennis ran. Well, first of all, I hope you all noticed that we were using a quite detailed 3D city model here, and we were not just displaying it. We were using it also for the vertical profile calculation along the route that Dennis was planning. And of course, it was used as input to this line of sight analysis. This specific type of line of sight analysis is something that we call the volumetric line of sight. So it gives you an indication not only of what you can see on the ground, but rather what of the airspace around you that you can see. And this, of course, is a really powerful feature for figuring out where to place your ground station or your pilot in order to keep the visual line of sight to your drone at all times. We're going to move on to the second example. And here the scenario is a bit different. Rather than planning a local flight in a detailed city, we're doing a mock-up here of planning and executing a recon mission over a much larger area. we're moving from Frankfurt in Germany all the way to the other side of the world here. We're using some data from New Zealand. In this case, we've used a data source or a data repository called GeoInt New Zealand. It's a very nice resource which provides a lot of high-resolution data sources over the entire country of New Zealand. And using Carmenta Engine, you're able to go to a data repository like that and then bring in or download the data sources that they provide, these really high-res data sources, and just plug them into your engine and instantly use them, both for visualization and for analysis. So there's no data conversion whatsoever going on in this demo. We've just used these data sources that we've downloaded from this public data repo. And you can do the same in virtually any part of the world and with any data provider, since the formats support is one of our real strong points in the engine. So let's have a look at what kind of analysis and planning support we can provide for this type of beyond visual line of sight planning. So going back here, we're going to start the second demo.
In this part, we move to Wellington in New Zealand. Here we have access to highly detailed elevation data combined with high-resolution aerial images. We are also using a data source to create buildings and combine them with aerial images. This elevation data will help us to analyze the terrain in our mission. Firstly, I'm going to move it to my 2D map. Now I'm going to start to create our mission routes. I'm going to start by placing some waypoints and then drawing the desired route. In this scenario, I want to simulate a reconnaissance mission. Here, my drone will map and take some pictures along the flown route. Thus, I want my drone to fly as close to the ground as possible. So, I'm going to start to analyze the vertical clearance for my flight. As you can see, the terrain analysis is activated on my 2D map and on my vertical profile. For this drone, I have configured it to analyze a buffer zone of 200 meters. This means that my planner is analyzing the terrain 200 meters around the route and showing the areas where my flight is below 200 meters safety altitude, as you can see in my 2D map here. We can also see the buffer zone here on the vertical profile. It will create the safe altitude buffer and display it against the terrain. This LiDAR profile displayed behind the route profile is the vertical profile with the highest elevation in the buffer zone. So it is possible to analyze the clearance and the profile, not only straight underneath the route, but also for a larger area around the route. Now I'm going to move some waypoints. Firstly, I want to adjust the altitudes for some waypoints and see how my vertical profile and my vertical clearance analysis look like. As you can see, the analysis is updated automatically while I'm editing the waypoints. And now, in this point, I have a safety altitude for my flight. Now, I'm going to adjust the first waypoint, which is the takeoff point. I'm also adjusting the second waypoint to adjust the first flight leg of my flight. I still have some red spots on my map, but that's okay because on this first leg, my drone will start to gain altitude. So this means it will be close to the ground. As you can see, the vertical profile and the vertical clearance is updated instantly while I'm editing the waypoints. And now, let's start with the simulation. If I select my drone, now I can see the terrain running around it. This terrain warning will display the areas that my drone's altitude is below the safety altitude, which in this case is 200 meters. If I switch to the 3D map, you can also see the terrain warning being projected on the ground according to the ground elevation. And of course, this is updated in real time while we have our drone flying around. If you are simulating or playing back a real flight, you can create a powerful environment to analyze your drone's mission. You can also combine high-resolution elevation data with other kinds of data sources. For example, sensors and communication equipment, and analyze the best location to set a command and control base, how to position your sensors, and other support vehicles for your mission. This will take your UAS to the next level.
Thanks a lot, Dennis. What did we actually see in this second demo then? Trying to highlight some of the most important features. Well, firstly, as I already mentioned, you could see that we were using various high-resolution data sources, both elevation data with a sub-meter resolution, an orthophoto, and also some building footprints downloaded from this public repo to build up both the 2D and the 3D environment, as well as the vertical profile, directly from that distribution format. You also saw an example of the vertical clearance analysis, which provided the colorization of the buffer zone around the route in the map view. And this is a type of analysis that's designed specifically for this planning scenario, where you want to get instant feedback on how adjusting your flight path, how that impacts the clearance of your flight. And using that in tandem with the dynamically updated vertical profile visualization provides a really good situational awareness for the planner. Talking about the buffer zones, yes, you could see that we applied both horizontal and vertical buffers to the calculation in order to ensure the safety. And of course, these are completely adjustable, as is everything else you saw essentially. The colorization and the limits and so on are of course all adjustable via our APIs when you integrate this into an application. The ability to actually take into account the buffer when doing the vertical profile, so that you're seeing the highest elevation anywhere within the buffer around the route, can be very useful when doing planning, in order to ensure that you're not flying into valleys which are too narrow, for example, so that you're susceptible for changes or sudden drifts. Yeah. Finally, when Dennis switched to the little simulation mode that we built into this demo, you could see the real-time terrain warning analysis. And this is something that you can attach to any moving object in the map, both in 2D and in 3D. And we will then colorize the areas around the object according to the distance between the object and the ground. Of course, just like with the vertical clearance analysis, the colorization is completely customizable. Digging a bit more into the technical details, the really cool thing about the terrain warning analysis is that it's calculated completely on the GPU. So if you're running on a computer, or for that matter, a cell phone with a dedicated graphics processor, then doing this kind of colorization in real time will not affect the CPU load of your application at all. It will just be the graphics card doing this real-time calculation. And thus you can ensure that this kind of safety critical visualization is not impacted by other high prior work that your application has to do. That's just one example of how we've designed our technology to be really resilient and to work well in these systems with high reliability requirements. Okay, so those were the main demos that we wanted to show you today. I'm gonna just check what the time is. I've been babbling away here for a bit. Yeah, we have a bit more time also for the questions. So I'm just gonna give you a few short demos of some of the other functionality in our toolkit, which we also feel is really usable in this UAS use case. Of course, there's much more to see. Of course, after this webinar, feel free to visit our webpage and browse through the available functionality. But highlighting a few things then. The ability that you can directly access aeronautical information can be of special importance for a drone planning station. Things like control zones around airports, restricted airspace, and these kind of things. You can read this information in the distribution format that the aeronautical authorities use. We support both the ARINC 424 and the AIXM format for bringing this type of information in. And once you've connected to those kind of data sources, you can use the information both to do analysis, for example, to avoid going into a restrictive airspace with your flight route. And you can also use it directly for visualization. Let's look at a quick example of that. I'm just opening up one of the samples that are included in Carmenta Engine SDK. We're reading an aeronautical data source now, and we're visualizing it using the engine in a typical en route chart fashion. So this is rendered directly from the distribution data format. It's visualized on the fly as I'm moving around here, as you can see. And of course, this type of visualization, when combined with other data sources, can really improve the situational awareness again of the planner or the pilots. Another feature which is designed for this kind of use case is our ability to handle geo-referenced video streams. We have a very flexible API for that. So regardless of the format of the video feed that's coming in, and regardless of how you're getting the metadata on where the drone is located and what the camera is looking at, you're able to take this information and feed it into our engine. And what we will do then is that based on the metadata on where the camera is, we will dynamically calculate the footprint for your video. And we will use that footprint to overlay the video stream geographically on both 2D and 3D maps. See, I have a little example of that as well here. So this is a little flight we conducted ourselves in the vicinity of Gothenburg in Sweden here. So we have a consumer drone, in this case, flying around here with its camera. We're downlinking the video stream together with the metadata on where the drone is and what the camera is looking at. And as you can see, the result is that we're having a very correctly geo-referenced feed that matches our background low-res satellite image here quite perfectly as the drone is moving around. So for the actual execution phase of your UAS mission, being able to downlink this kind of data and get the video feeds combined with your maps can be a real game changer. Yeah, I can see the drone is now starting to follow a vehicle here that's driving along the route here. Yeah, finally, I want to mention that the line of sight functionality, which Dennis used to position the pilot or position the ground station for the visual coverage of the flight, can also be used for other things. It can be used in an air-to-ground scenario, where you're actually analyzing the coverage of the sensors on board your drone. Let's look at an example of that as well. I'm opening another sample that it's included with our SDK here. It's now loading in some data sources and building up a 3D map on the fly. In this case, we're using OpenStreetMap data for the building polygons. So we're not using any detailed 3D data or orthophoto in this example. The purpose is to make it easy for a developer to understand how this line of sight functionality works in order to be able to integrate it into her own application. So you can see we have, in this case, actually 2 observers placed in the map. And if we start moving them around, you can see that the air-to-ground coverage is calculated instantaneously. Of course, this is also something that's done completely on the graphics processor, on the GPU. So adding this kind of analysis to your application will not affect the CPU load at all. Changing the altitude of one of these observers here, you can easily envision that this is actually a drone flying over this area, and the coverage would then show the the coverage of the onboard camera of the drone, for example. So yeah, that's a very quick look at some of the other functionality in our toolkit, which can really be used to improve the functionality in your planning station or in your actual ground control station where you're controlling your flights. Okay then, that sort of brings us to the end of what we wanted to present at this webinar. But as I promised before, before we wrap up, we'll do a little questions and answers session where you'll get a chance to ask any questions you have using the chat functionality in the Zoom client. So Dennis, I suppose you've been keeping a look at the chat during the presentation here. We got any interesting questions from the audience that we want to answer towards the end here?
Yes, we have a question here from Aragon. Sorry if I'm not pronouncing it correctly, but he's asking, hello, are trees altitudes also available in the 3D map for low altitude flights?
Oh, so the question was whether trees can be taken into account when doing the planning. Absolutely. Yes. That depends on the type of data sources that you have access to. If you have an elevation data source, which also includes vegetation and so on, that can also be taken into account when doing the analysis. And as I explained earlier, we are very flexible when it comes to the type of data sources that you can bring into the map here. Yeah, I mean, feel free to get in touch with us after the webinar and we can discuss potential data providers for that kind of information in more detail.
Yeah, I think we can also say that if you have like vegetation data, you can also integrate it with the vertical profile that we've seen in this video.
Absolutely, that's a very good point, Dennis. So in the vertical profile view, in the examples that Dennis showed, we were just using elevation data sources for the profile. You can feed so-called land use data, data which classifies the terrain into forest, open land, and so on, into the vertical profile, and actually show the types of terrain that you're flying over. Can't help myself here. I'm going to open up a little example of this as well. That's another thing that's included in our SDK, actually. So this is an example of a more complex vertical profile view, which is cutting through not only elevation data sources, but also other things like airspace, for example. That's not something that we chose to include in this particular demo, but you can just as easily cut through your restrictive airspaces and so on using the profile. And also when doing the 3D line of sight analysis, you can take into account any restrictive airspaces and so on. But in this profile view, you can see that we're actually flying over some different types of terrain here, some evergreen forests, some shrubs, some grass, and so on. So if you have that kind of classification data or land use data, that can also be used directly in our technology, both for visualization and for analysis. Okay, was there some other question?
Yeah, we have another question from Aragon. He's also asking, what's the accuracy of the elevation terrain?
Okay, well, that really depends on the data source. There's no restriction in our technology on how high resolution data sources you can use. We are very good at adapting the resolution which we use depending on the zoom level of the map and so on to ensure that you always get a responsive result. I'm not exactly sure what the resolution was of the elevation data we were using for New Zealand there. It might have been a 1 meter resolution, a ½ meter resolution data source, I think. That's something that we can check and get back to you later on as well. Of course, the high-res 3D model we were using for the Frankfurt demo from the N-Frames company has even higher resolution than that. If you zoom into that model, you'll see that it very accurately models individual buildings and so on. Again, unfortunately, I don't have an exact accuracy measurement right now. We will have to check that and get back to you. But we don't put any limitations on the sort of accuracy of the data sources that you feed into our technology. It's very much data agnostic, essentially.
Yes,
Okay.
and I think that's all the questions that we had from our audience.
Okay. Oh, that's pretty good. I don't mind ending a couple of minutes early here. So, so then I guess we'll wrap it up for today. Thank you all for spending the time to listen to us. I hope you found this presentation interesting, and that it gave you some ideas on how you can use our technology to sort of supercharge your planning stations or your ground control stations. Feel free to get in touch. You see some contact details on this slide. Feel free to just send us an email asking for a follow-up meeting, or also in many cases I think you will have been in touch with one of our account managers, and rest assured you will hear from us after this meeting. We will contact you and get some feedback on what you thought about the webinar, and if there are other things you want to discuss. But as I said, we're open for business during these strange times, so all our communication channels are available. Feel free to contact us. So with that, I just want to thank you all again. Have a nice day, and we'll keep in touch. Thanks a lot. Bye-bye.
Thank you.